Dear students, in this lecture we are going to discuss about the electron capture. Electron capture is basically it is a radioactive process in which an unstable parent proton of the parent nuclei gain electrons from in orbits, and during the gain of proton by gain of electron by a proton in unstable nuclei of an atom result into conversion of unstable parent nuclei of an atom into a stable daughter nuclei, and in this process highly energetic gamma rays are produced. Such type of process in which electron is caused the conversion of proton into neutron, and as well as its emit gamma radiation is known as electron capture. So dear student, please let us write the definition of electron capture process. Electron capture is basically it is a radioactive process. It is radioactive process in which electrons are gained by the protons of unstable radioactive parent nuclei or atoms, result into formation of neutron along with high energetic gamma radiations is called electron capture. So in dear student, if I represent it schematically in electron capture process, an electron, suppose this is a schematic representation of an electron, and this is a schematic representation of proton which is present in a daughter nuclei. So the electron which is present in a parent nuclei. So electron of the parent nuclei basically is attracted by a proton of the parent nuclei, or electron of the parent atom is gained by proton of the parent atom. So when electron is gained by proton of the parent atom, the parent atom proton is converted into neutron. And due to conversion of proton into neutron, the parent atom is basically form a new type of atom which is basically known as daughter atom, and nuclei of this atom is known as daughter nuclei. So along with the formation of daughter nuclei, there will be a release of highly energetic radiations, and these radiations are known as gamma rays or gamma waves. So in electron capture process, electrons are basically gained by by the proton of a parent element. Electron is also present in a parent element, and protons are also present in a nuclei of parent atom. So the electron of from the orbit of the parent atom is gained by a proton which is present in the nuclei of the parent atom. And by gaining a proton, by gaining electron by a proton, the proton is converted into a neutral particle neutron. Hence, in this way, a daughter nuclei is formed, and by conversion of the proton, electron, converting a proton into neutron basically also produce electromagnetic radiation, which are highly energetic, and these radiations are known as gamma rays. So now we can also represent this with schematic diagram like this. In as you know that the atom basically consists of a nucleus, and nucleus of an atom consists of neutral charge particles. Suppose the atom of the nucleus has a neutron, and it also consists of positively charged particle known as proton. So nucleus of the atom has neutrons and as well as protons. Neutrons and as well as protons. So in electron capture, the electrons, as you know that electrons are basically present in the orbital around the nucleus of an atom. Suppose we have electron, suppose this is the representation of electron, it is present somewhere in the orbital of the parent atom. So electrons are basically gained by the proton of the parent atom. So when electron is gained by proton of parent atom, the proton is basically is converted into a new particle, and that is basically it is a neutron. So in this way, the parent atom basically is converted into a new daughter atom, since the number of basically neutron are increase, and they will basically result into change of a parent atom into a daughter atom, and along with the daughter atom there will be a release of highly energetic radiation, and these radiations are known as gamma rays. Now dear student, please keep in mind that there are different types of decays, such as alpha decay in beta decays, and as well as positron decay. Positron decay. In all these three types, particles are basically released in the process of decays. New particles or additional particles are basically released. Whereas in case of electron capture process, particles are basically gained. So this means that alpha decay, beta decay, or positron decay are different in a sense that in electron capture, electrons are basically gained, or particles are basically gained, whereas in alpha decay, beta decay, or positron decay, particles are basically released from the radioactive nuclei. So now, dear student, let us write chemical equation for the electron capture process. Consider that we have an element X, and since you know that in periodic table elements are represented by their atomic number and as well as atomic mass. Atomic number represent number of protons or number of electrons, whereas mass number is represented by number of protons plus number of neutrons. So the element X, the atomic number and mass number of element X will be represented in subscript there will be atomic number, whereas in superscript there will be a mass number. So now consider this element is going through electron capture process. So this means that the nuclei of this element will basically gain electron. So when the nuclei of this element basically gain an electron, there will be a change of parent atom into a new daughter atom and as well as daughter nuclei. So suppose that this X atom is converted into new daughter atom, which is Y atom. Since electrons are basically electron of the parent atom, basically they are gained by uh, by the proton of the parent atom, and this means that the number of when the proton gain electron, the protons are basically converted into neutron. So this means that number of proton is basically decreased by 1, and you know that number of protons are represented by atomic number. So this means that atomic number will be changed from Z to Z minus 1. So we will write in daughter nuclei the atomic number of daughter nuclei or daughter atom will be decreased by minus 1. Whereas since the proton is since in electron capture, electron basically is gained by proton, and protons which are present initially will be converted into neutron. This means that the protons are converted into neutron, but as you know that atomic mass is represent a number of proton plus neutron. So the one proton is basically converted into neutron, so there will be no effect on atomic weight. Only proton is converted into neutron. So the daughter atom will have uh, atomic weight which or atomic mass which will be same as to a parent atom. And in this process, new type of radiation will be released, and these radiations are known as gamma rays. So this is basically a reaction, nuclear reaction for electron capture process. In electron capture process, atomic number is basically decreased by 1. Z is decreased by 1 for daughter nuclei, and whereas atomic mass or atomic weight is remain constant or it remain same. So dear student, please remember these rules for electron capture process. In electron capture process, basically the atomic number is decreased by 1 for daughter nuclei, whereas atomic mass of daughter nuclei remains same. So in this way you can basically solve problem for electron capture processes. So now consider we have an element, suppose we have potassium 40, and this potassium 40 go through electron capture process. Nuclei of potassium 40, the proton present in a nuclei of potassium 40 gain electron. So the new daughter nuclei, as you know that according to rule for electron capture, the atomic number basically decreased by 1. So the new nuclei will have the atomic number of new nuclei will be 18, whereas the atomic weight of new nuclei or new atom remains same. It is 40. So we need to check in periodic table what element has an atomic number of 18. If we check it, we can find that it is basically argon having an atomic number 40, and in this process gamma particle will be released. So in electron capture process for potassium, potassium is basically the atomic number of potassium is decreases by 1, hence result into change into a new element or daughter element known as argon, and along with that a highly energetic waves or radiation will be produced, and these radiations will be gamma radiations. Now consider another example. We have nickel. We have nickel 59, and this nickel 59 goes through electron capture process. So as you know that in electron capture process the atomic number is decreased by 1, so the new element will have an atomic number of 27, whereas atomic weight remains same. So the atomic weight of new element or new daughter element will be 59. So we need to check in periodic table which element has atomic number equal to 27. We can easily find that it is a cobalt. So it is a cobalt, and along with the cobalt there will be a release of a gamma particle. So this means that the electron capture process of nickel, nickel is converted into cobalt, and along with that there will be a release in a gamma particle. Now let us solve some of the problem for electron capture process. Suppose we have electron capture process, and in the result of electron capture process we found new element, that we have magnesium 12, 26, and along with a gamma particle, and we need to know that which type of element goes through electron capture process which result into production of magnesium. So in a sense you know that in electron capture process basically the atomic number of daughter nuclei is decreased by 1. So this means that atomic number of daughter nuclei is less than 1 for the atomic number of the parent nuclei. This means that atomic number of parent nuclei will be 13. So we can write that atomic number of parent nuclei is 13. Whereas in electron capture process, the atomic weight remains same. So the atomic weight of the parent atom will be 26. So we will write atomic weight of parent atom 26. So now we need to check in periodic table that what is the element having an atomic number of 13. So we can easily find that it is an aluminum having an atomic number of 13. So we can write electron capture process for aluminum like this. So basically, if we have the element which gone through the electron captured process, and if we have a daughter element, from daughter element we can find a parent element by simply applying the rule that atomic number of daughter element is 1 less than the parent element, and whereas atomic weight of the parent element remains same to the atomic weight of the daughter element. So this is all about electron capture process. Let me conclude the electron capture process. Electron capture process is a process, it is basically a radioactive process in which electron is gained by a proton of the parent atom, and when a parent electron of the parent atom is gained by a proton of the parent atom, the protons, the parent atom, result into conversion of neutron, and hence new daughter atom is formed. And as a result of formation of daughter radiation, the gamma, as a result of the daughter atom formation, a new type of radiation which are known as gamma radiations are produced. The process a in which an electron is gained by a proton and its result into a daughter nuclei and gamma radiation is known as electron capture process. So this electron capture process is slightly different than beta decay or alpha decay, because in electron capture process, electrons are basically gained by the particle is basically gained by a radioactive nuclei, and whereas in alpha and beta decay, the particles are basically released from the parent radioactive nucleus. So this is all about electron capture process. So thank you for watching this lecture.